All right. So today we're going to look at factoring polynomials. So we're going to step it up a little level here. The first thing we're going to do is what I would call a little warm up here. So we're going to look at the 3 steps that you need to go through whenever you factor easy polynomials. Okay. So number 1, is there a common term? Factor out a common term. So when I look across this polynomial here, if I'm supposed to factor it, it actually looks really ugly. But the first thing I notice is that there's a 4 in the first term, there's a factor 4 in the second term, the third term, and the last term. So I can factor out a 4. This is the opposite of the distributive property. And then I also notice that there's x to the 4th here. That means there's 4x's being multiplied, 3x's being multiplied, 2x's being multiplied, and a single x being multiplied. So I can actually take out this x, but I'm going to take out a single x from the 4th term, the 3rd term, the 2nd term, and the 1st term. So that's x to the 1st. Now, what's left after I factor that out? The easiest way to do this is to divide each one of these by 4x. All right, I apologize if this is a little small here. 4x, 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 and 4x. That's the easiest way to determine what's left whenever you're factoring out a common term. 4x to the 4th divided by 4x is x cubed. 8x cubed divided by 4x is 2x squared. 12x squared divided by 4x is 3x. Oops, and there was a negative in front of that 12, so I got to be careful with that, don't I? And then 4x divided by 4x is 1. That's right, you have to leave something there. Okay, so that's step number 1, always look for a common term. Step number 2 is to factor a difference of 2 squares. Now, we did some polynomial factoring the other day, and this polynomial is the same thing as 9x squared plus 0x minus 25. So you should be able to box that or plus that. I'm just going to look at it as, again, what 2 terms multiply to 9x squared, what 2 terms multiply to negative 25. Well, most of you guys would probably guess 3x and 3x for the front term. So 3x, 3x. And then what times what multiplies to 25? Well, 5 times 5 is a pretty good answer, but one of those 5s has to be negative because the 25 is negative. So we're going to go plus 5 on one and minus 5 on the other. Doesn't matter which order, they're both the same, right? So that's called a difference of 2 squares. The reason we call it that is because both of these terms, if you remember from simplifying square roots, these are both perfect square terms. All right, perfect square terms. And you can always throw a 0x in between there. Okay, now the other thing we looked at was factoring trinomials into binomials. We did some easy ones like letter A, and I'm just going to give these answers because we're going to be doing some more of this today. This one would be, again, 2 numbers that multiply to x squared. That's going to be x and x. 2 numbers that multiply to negative 10. In this case, that's going to work out to be negative 5, positive 2. I can do the same thing over here. I don't even know what the answer to this is right now, but I know it has to be 3x and x. And then I need numbers that multiply to negative 8. So I'm going to take a pretty good guess here that this is going to be plus 4 and minus 2. And I think I've got it. If you FOIL that back together, it should work. So whenever it says to factor something, the first thing you want to do, number 1, is there a common term I can take out? Might make it a little bit easier. We did that in warm-up number 1. Number 2, is there a difference of 2 squares? We did that in warm-up number 2. Number 3, can I factor trinomials into 2 binomials? Okay, we talked about this the other day. These are called trinomials. Excuse me. These are called trinomials. These 2 things down here are called binomials. Okay? And so today what we're going to do is we're going to look at factoring trinomials into binomials, but we're going to be doing 2nd degree, not only 2nd degree, but 4th, 6th, and so on and so forth. And then we're also going to look at number 5 here today. and that is we're going to look at factoring 4-term third-degree polynomials, and we're going to do that by a method called grouping. So you'll see that on the next page. All right, so if I said factor example number 1 here, you look at this, and this looks exactly like one of our problems in the warm-up, like maybe x squared minus 2x minus 15, right? Kind of looks the same, except the exponents are a little bit different up here. That's okay, all right? I'm going to factor this trinomial exactly the same way I would factor this blue trinomial. If I said to factor the blue one, you should be able to come up with x minus 5 and x plus 3. Now, it might take you a little bit longer than that, and that's okay. You can do that, but with a box, with a FOIL method, or with a plus method, you should be able to come up with those two factors. Now, here's the nice thing about this. Because this has 3 terms, and this guy has 3 terms, we'll talk a little bit more in a minute, I should be able to factor this guy the same way. So I can start off with x minus 5 times x plus 3, but here's the thing. If you multiply that back together, you're only going to get x squared. You need x to the 4th. So I need to change these exponents on the x's to be squareds. That's it. Notice my squared term in the middle here? When I go to FOIL this back together, watch what I get. I get x times x, which is x to the 4th, x squared times 3, which is 3x squared, negative 5 times x squared, which is negative 5x squared, and negative 5 times positive 3, which is negative 15, and it matches up with the original problem. The reason I can do these guys like this is for this highlighted section you'll see right here. Notice that the middle exponent is half of the first. Take a look at these guys right here. This exponent in the middle is half of this first exponent. If that's the case, and it's a trinomial, I can always try it with the box or the plus sign to try and factor this. So what I want you guys to do is take a minute and try and factor this. If you have to, just pretend it says 2x squared minus 11x plus 12, and then change your beginning exponent back to squareds. So I'm going to do the plus method on this one. So I know that to get 2x to the 4th, I would need 2x squared times an x squared. To get positive 12, I would need, I don't know, it could be 3 and 4, it could be negative 3 and negative 4, it could be 2 and 6, it could be negative 2 and negative 6, and I don't even have them all, do I? 1 and 12, negative 1, negative 12. But you know what? I'm just going to start at the top of my list. I don't need positive 3 and 4, and the reason I know that is because there's a negative in the middle term here. So all these positive terms are not going to work. So the next thing I might try is a negative 3 and a negative 4, and I think I'll do those first. Negative 3 and negative 4. So I'm going to factor these guys, okay? Now, if I check my middle terms, or I'm going to multiply these guys, excuse me. So I know that this is 2x squared on the left. I know that this is 12 on the right. All I'm doing is checking my middle. 2x squared times negative 4, negative 8x squared. Negative 3 times x squared, negative 3x squared. If you add those together, you get negative 11x squared. All right? Which means that my factors here are 2x squared minus 3 and x squared, whoops, forgot my other parenthesis there, and x squared minus 4. But we just talked about a special case in the warm-up, and that was this guy right here. What do you notice about that 4 there? It's a perfect square, isn't it? And by the way, x squared is a perfect square. This thing here is called a difference, D-I-F-F, there we go, a difference of two squares. Difference means minus. I see the minus in between. Two squares means I have two perfect square terms on either side of that minus. If it's a difference of two squares, notice that I can factor x squared into x times x. The number 4 factors into 2 times 2. All I got to do is remember that one of those 2's has to be negative. So that will factor into x plus 2 and x minus 2. And then I can drop down my other factor. Notice it is not a difference of two squares, because 3 isn't a perfect square term, and neither is 2. So that's it. This polynomial actually has 3 factors to it. Kind of kooky, huh? All right, let's go to the next page. All right, so we're going to do 2 examples of factoring bigger polynomials. If you look at this polynomial here, kind of looks like that first one we saw in the warm-up there, but it's definitely not, because there is no common term here. So we're going to try and factor these by grouping. We call this a cubic polynomial. Cubic means 3, so that's a 4x cubed polynomial. All right, and what we're going to do, your steps are over here on the right side. So these are your steps. So we're going to go through the steps. We're going to group the first 2 terms and the second 2 terms in parentheses. So I'm going to take my first 2 terms, 4x cubed minus 3x squared. I'm going to put that in parentheses. Notice I'm leaving a little space in there. You'll see why. I'm going to group my last 2, negative 8x plus 6. That's my first step there. My second step says to drop a plus sign in between. So I'll just go ahead and do that right there. That's why I left the space in there. My third step says to factor the greatest common factor from each set of parentheses. That's it. Just take out a GCF. So I'm going to look at my first set of parentheses here. 4 and 3 have nothing in common, so I can't factor out any numbers. But x cubed, remember, x cubed is really x times x times x, so there's 3 x's there. X squared is x times x, so there's 2 x's there. So they have 2 x's in common here. So I'm going to factor out those 2 x's, and I'm going to call that x squared. Now, if you remember, to find out what's left, all we have to do is divide each of these terms by x squared. Well, 4x cubed divided by x squared is 4x. 3x squared divided by x squared is 3. There's your first one. Go to the second one. 8 and 6. I can definitely factor out a 2. I can't factor out any x's because the 6 doesn't have one. But notice this 8 is negative. If this term here is negative, then I'm going to always factor out the negative with the number. Okay? So now, again, we divide. What's negative 8x divided by negative 2? That's positive 4x. What's 6 divided by negative 2? That's negative 3. Hey, look at what just happened here. These 2 factors right here match. In fact, they must match. If these guys don't match, then this thing is either done wrong or it's not going to factor. Okay? These guys have to match to go on to the last step. Now, in this last step, I'm going to do a little bit of work over here on the side. So I'm going to do kind of like a calculus thing here. I'm going to introduce you guys to something called a substitution for variables. Okay? And it's actually called a U substitution, but I'm not going to use U. I'm going to use a different letter. So over on the left side here, instead of 4x minus 3, I'm going to let W equal 4x minus 3. Okay, so I'm going to rewrite this red polynomial here, but instead of 4x minus 3, I'm going to put w in its place. Okay, so I would have x squared times w minus 2 times w. Okay, so all I did was take out the parentheses and put in a w. Now I want you to look at my last step right here. My last step says factor the common factor from each grouping. Notice my groupings down here. What could you factor out of this? This term contains a w, and this term contains a w. Just like this term back here up top contains a 4x minus 3, and this term contains a 4x minus 3. These are common factors, just like these w's are common factors. So I'm going to factor out a w. That's going to leave me x squared in front and minus 2 in the back. But when I get all done with this, whoops, I have to make sure that instead of w, I put the 4x minus 3 back in. So I would put the 4x minus 3 back in, and I would have 4x minus 3 times x squared minus 2. Now, there's an easier way to do this. You don't have to do this little w substitution here. So I'm going to come back over to my problem, and I'm going to highlight this piece, and I'm going to highlight this piece. This is x squared times 4x minus 3, and negative 2 times 4x minus 3. These guys here are my common factor. When I get to this point, the reason these guys have to match is so that I can literally take one of these guys and factor them out into the front. I'm going to factor both of those guys. So I'm going to have 4x minus 3 in the front. And once I factor those out, you got to imagine they're now completely gone. So if you put your fingers over those two yellow spots for a minute, all that's left is x squared minus 2. X, maybe if I can write, Not sure what happened there for a minute, guys. I lost it. All right. So this is x squared minus 2. All right. Now, I'll be honest. Once you do this a couple of times, this is about a 3-step process. You can see there's not a whole lot in there. So if you think you're comfortable enough to do it, I would definitely encourage you to try this next one on your own. Step number 1, group the first two terms, 4x cubed minus 6x squared. Group the second two terms, 10x minus 15. Put a plus sign in the middle. That's step 1 and 2. Step 2 is to factor out a common factor from each grouping here. In the first grouping, I know that 2 goes into 4 and 6, so I'm going to factor out a 2. I also know there's 3 x's next to the 4 and 2 x's next to the 6, so I can pull 2 of them out. That leaves me, again, all you got to do is divide 4x cubed divided by 2x squared. That is 2x. 6x squared divided by 2x. That's 3. All right, I go to the next set. I do the same thing. I can factor out a 5. This time it's positive. I can't factor out an x. 10x divided by 5 is 2x. 15 divided by 5 is 3. Look at that. My factors match. The whole idea in factoring by grouping is to now factor out a 2x minus 3 from there and a 2x minus 3 from there. So when I factor out that 2x minus 3, literally put your fingers over those and look and see what's left. 2x squared plus 5 is what's left. All right? 3 steps and we're done. Pretty easy, huh?